Hey guys, it's the Xbox Nut, and I've got another video for you on the CPU that I'm making in Minecraft. I've made the code I don't know whether to call it the code runner, because that sounds a bit weird, or the code reader. That kind of sounds better. But basically, in the last video you've seen up to this dirt. Oh, I'm lagging a bit. Which are the registers for the instruction, I think. I remember I flipped over there. I'll show you actually because the fog's down because I lag a bit because my connection is not very good. My speed isn't very good when I'm recording. But I remember one of the instruction and the value. One of them goes up and one of them goes under. But I can't remember which one's which. It doesn't matter at the moment, but one of them. So that's the instruction input. I think that goes up. So these are the that's the value register, value input. So they go above. So I think these ones are the value holders. And what I've got lined up here is it's another program counter, which consists of a 3-bit binary counter and a 3-bit decoder, just like the one over here. And it feeds into these buses, and they enable another set of enablers on the output of the D flip-flops, and so it will control which set of instructions and values gets output at a time, and it will cycle through them in an order through the clock, which is here. And so we will have a fully working program counter that we can feed into an ALU, and we will have completed the CPU. So, whoops, let's put the fog back on because we don't really need it very far. And I'll explain what I've done and how it works after I give you a little demonstration. I've already coded a program. It doesn't do anything because obviously it's not hooked up to an ALU, but it cycles through instructions and values here. So the top one is the value and the bottom one is the instruction. This is basically the button that says run CPU. It's here. It will be you will be able to access it from the control panel when it's finished, but for now it's here. So the first instruction or program bit is all on. That's the first of one of 4 instructions. The second one is just value 15. It doesn't actually mean anything at the moment. Second one is instruction 15. And the fourth one is all of them on again. That's just a simple program so that we know that it's actually working because it's had all of them on and all of them off. And it's easy to tell. It's just easy. It's nice, just a simple pattern really. Stop the counter. And now I'll explain to you how it works. So as I said, it is a program. Another program counter, but instead of putting the data in to these registers, it takes them out in an order. So it's got the exact same program counter made by X on the forums. Bit of trick wiring here because the inputs are reversed in this decoder. So you just flip the left one to the right and flip the right one to the left and put the middle one through. And we've got our counter. Reset that. There it is. And basically, this looks very complicated, but I assure you it's not. Every bit has this same design of a wire going up here into this torch. Every single bit, and it just keeps on going. And every 4 are linked. So this 4 is linked. That's the first. I think these are the instructions. So this is the first instruction, and above here on this platform we have these are the enablers, these lines of 4, and so when the program counter hits the corresponding enabler, it will let that data through and it will do it in order. But these are the data outputs. So this enables the data to go through, but these actually carry the data from the AND gates. So first instruction is this one. You press the run button. It will enable these 4D flip-flops, whatever values they're holding will be enabled, and they will run along the bus lanes, and those bus lanes will go towards the center underneath these outputs. I won't be able to get to it from here. They will run here. This is the bit 1 output, which is connected to all bit 1s of all the instructions. This is bit 2, connected to all bit 2s. This is bit 3, connected to all bit 3s, and bit 4 is connected to all bit 4s. And so each bit is run into the middle. These ones, the bits over here, the last couple, are run towards it, and so are the ones over here, so that the output goes through the middle, which means that there's minimal, it means that everything's got the same delay, so no instructions are faster than others, because that would just be annoying. And so they're run here, and once the program has run all 4 of them in a line, once one of them has been run, the ALU will receive the instruction, it will receive the value, and it will receive the operation that's being done, or the other way around, operation value, whichever. I always forget. And so the ALU, like my previous one, will calculate the value with all the operations in a line, and the operation will go into another decoder, which will enable a specific output to be able to travel, and that output will loop back into the ALU, and then by that time, in theory, the second value and its operation will occur, and then the initial instruction will calculate its new operation with the new value, and that will happen 4 times, and then the CPU, that is basically the CPU, it runs 4-bit instructions. So, I'm sorry I haven't had a video in a while. I've got a lot of work to do, and unfortunately I can't really spend most of my time on a Minecraft game, on a Minecraft CPU, although I would love to. I love entertaining you guys. But yeah, so I can't really spend a lot of time on it. So I try to get videos out as often as I can. The CPU is very almost finished. Part 3, I tend to just go along with what I'm thinking about. I don't want, I'm not even sure if this might work. I doubt it, but I might have to rip this all out for the ALU, because I have no idea how the ALU is going to function. I just have to go with it. And so the plan is feeds into the ALU, comes all the way back, and I need to adjust the clock to a reasonable timing, and I'll calculate how many hertz this is, I think, in the description. I have no idea I think each of these is 4 ticks, so I just add them up. So yeah, that's my code loader, and code running. The code, you load the code. In fact, you know what, I'll do another demonstration so that you know it actually works, and we'll load in our own code again. We'll do some more awkward ones, not just regular patterns. So yeah, that's the control panel. I still don't think I'm going to be using these 4 bits of value inputs. Oh, and another thing, a lot of people with CPUs tend to just put the torch like this. Now for me, I don't really like that. I think it's quite annoying, because down is on in most things, up is off. And so if you're wondering how I did that, which some of you might be, it's very basic, but still quite useful. There's a torch on the back of the lever, goes into a block, and on the other block, on the inside of the block, is a torch on it. And that's it. Most people don't bother with that because it's a waste of time, but it only takes about 5 seconds. You can still put the torches right next to each other like this, and it just makes it look a lot better. So I prefer that. And it's getting dark, so we'll load our code and then we'll run it in the morning. So it's back on 0. Oh, and I shortened the monostable timing because it went on for quite a while, but I took that off. So let's say 15 for the instruction and 6 for the value. I like to check that it's going to run, yep. And then we'll do this. I'm just going along with it. Cool. And then this. 8 for the instruction and 15 for the value. And we'll just the classic 1010. Oh, and in case you guys are interested, I might be doing a let's play soon. It'll have to be a server because I am shit scared of spiders, so I can't play it on my own, man. Even though it's a game, I would just freak. So I'll have to find a friend who wants to do that. I've been planning to do one with a friend, but we have to wait until he's got a good computer. His current one's quite slow. Well, it's quite good, but when he's running fraps on it, it's kind of slow. So I'll have to wait for that. He's going to be doing server let's plays with like 3 or 4 of his other friends. So when that starts, I'll let you guys know, because I'm sure he'll want me to let you know. So yeah, we've loaded our code. Hop onto this little stand. And let's watch it play. That's 6 and 15. Oh, so the top one is the instruction. What was it? I can't remember which one it was. This. I remember it. We're reading it backwards at the moment, because it will feed into the ALU the right way round. So it's going to be backwards when we're facing it this way. And 1010. And so there you have it. My 4-bit CPU is really coming together. I will work out how many hertz this clock is and put it in the description. Although it will probably change, just depending on how long it needs to be. And yeah, thank you for watching, and stay tuned for more CPU stuff.